Hopefully you spend at least 5 minutes working on this problem. So now I'll give you the solution. If you got 12 possibilities, then you are correct. So I will get all the possible combinations using a systematic way. I didn't teach you this because I wanted you to think a little, but we can figure out all the possible combinations by drawing a tree diagram. And I will do this by drawing something that you could probably call a stage. Now I have a choice, so this is my first stage, and for my first stage I'm going to have two options. And my two options here are going to be veggie burger or hamburger. Reiterating, for stage 1 I have two choices. Now these two items are part of my second stage, or I'm just going to label this as stage 2. And now each item on stage 2 also has two choices. And that's due to the beverages, because for beverages we can either have a soda or we can have a tea. So here my veggie burger has two choices, soda or tea, and my hamburger has two choices, soda or tea. And each item that resulted from the second stage now has three choices. And the three choices come from the salad. We can either have garden, potato, or macaroni. So again, each item here is going to have three choices. So here let's call this stage 3. So stage 3, each item is going to have three choices. So this soda can have a garden, potato, or macaroni. And the same for the other three on stage 3. And to get all the possible combinations that exist of one burger, one beverage, and one salad, all we gotta do now is count how many leaves were towards the end of this tree diagram. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have a total of 12 choices. And since we have all of the information for fun, let's just write them out. For example, here we have veggie, soda, and garden, so that's one choice. We also have veggie, soda, and potato, that would be a second choice, a second combination. And then we have veggie, soda, and macaroni, that would be a third combination. We can also do that for this one. So we have veggie, tea, garden, veggie, tea, potato, veggie, tea, macaroni. Next, we can start the ones with the hamburgers. So we have hamburger, soda, garden, hamburger, soda, potato, hamburger, soda, macaroni. And finally, we have hamburger, tea, garden, hamburger, tea, potato, and hamburger, tea, macaroni. And here are all 12 possible combinations. Tree diagrams are good at helping us discover how many possible combinations there are when you have certain stages. But I propose a much faster way of counting. So I'm going to use some placeholders. And each placeholder is going to represent one stage. So if we look at stage 1, each item in stage 1, well, there's only one because that's your choice, but each item has two choices here. So I'm going to write a 2 right here for two choices. My choices are hamburger or veggie. Now if we move on to stage 2, each item on stage 2 also has two choices. Right here we have the choice of soda or tea. Here we have the choice of soda or tea. So for stage 2, I'm going to write a 2 again. This 2 represents a soda or tea. Now if we move on to stage 3, on stage 3, each of these 4 items had 3 choices. Each one of them again had 3 choices, garden, potato, or macaroni. So for stage 3, I'm going to write 3. So in order to get all possible combinations, we could have just counted all of the leaves on our tree diagram, or we could just get the product of each stage here. So the total number of combinations would be 2 times 2 times 3, and here we have 12. So sometimes we're not necessarily interested in knowing each different combination. We're more interested in knowing how many possibilities exist, because once we know that, we know what the sample space would be, and once we have the sample space, we can start applying a bunch of different probabilities. And this leads into the fundamental counting principle, which we're going to discuss on the next video.